My name is Harrison, and I'm back to my channel. Welcome back. We have done introduction to chemistry, and we have to move further. Yes, and today we'll be looking at matter. Matter is very, very important in chemistry. Very, very important. Why? Because chemistry is a branch of science that deals with matter and changes. So chemistry involves matter. So matter is a very important topic in chemistry. Now, what is matter? Matter is anything that has mass and can occupy space. Yes, example: air, table, board, book, marker. Me, our body, you, and whatsoever. All human beings are matter. Everything God created are matter. Yes. Now, once we look at the changes in matter, changes of matter, we have the solid, the liquid, and the gaseous. Solid, properties of solid: they are tightly packed and they have intermolecular force bound in them. Yes. And they don't move randomly. Yes. And they are not compressible. 2, we have the liquid. The liquid that are slightly move freely and randomly. 2, they have intermolecular force binding them. That is, they have weak kinetic energy. And we also have 3. In liquid is not compressible. We all already know that. And in liquid, yes, they move randomly. Then third, we have the gaseous. The gas, they are compressible. Yes. Experience this thing. Bring a can. There is no water in it. Just squeeze it. If possible, I can do it, but it is a homemade mini assignment you can do. Just bring a can, squeeze it. See, immediately you do it, the can will do what? Squeeze. That means that air do what? Evaporates and leave that place. So gas is compressible and they move randomly. They move in a zigzag direction. What I mean? Air normally, for us, air moves randomly in a zigzag way, just like Brownell's motion. You know Brownell's motion, right? Good. Brownell's motion is just movements or constant rapid of particles in irregular direction. That's how gas moves. Then it has a very negligible kinetic energy. Let's say that it does not have, but it has. It does not have, but it has. Let's say a little. Let's say a little. Okay, we move into the changes of states of matter. We have the example. We have evaporation, condensation, sublimation, and freezing, melting, and so on. Melting is a process in which a solid is turned to a liquid. Just like melting, ice melting from a solid. When you bring ice from a freezer, it melts. It melts to what? To liquid. We have sublimation. That is solid to gas. Now when you bring your solid, it evaporates as a thin air. Example, your comfort. you all know your camphor. When you just drop camphor in your bag, come, let's say, a month or something, some weeks or something, you will notice that the camphor is already reducing in size and shape. That shows that sublimation occurs. Good. We also have evaporation, that is liquid to gas. Liquid what? To gas. Example, you're cooking. When you're cooking, you notice that your cover of your pot, your cover of your pot, good. Your cover of your pot, you notice that there's a water under your cover of your pot, good. So at some time, they do what? It evaporates. Condensation, still on that cooking. That is your gas to what? To liquid. The gas to liquid. It just vice versa of evaporation. That's your gas. Then when you open your pot, you will notice that the water will do what? When you after cooking your beans or something, so your water entered inside the beans. Most of the water is entered inside the beans before you remove the pot. Do you understand? That is actually condensation. Now we have freezing points. Freezing, and it's also called fusion. That is process of liquid to solid, just like your ice. When it turns to that liquid, when you put it inside the freezer again, it will do what? It will become what? To turn to ice, right? Good. As is freezing point of what? 0 degree Celsius. That's good. Now I want to look at physical changes and chemical changes. In physical changes, new substances are formed. New substances are not formed, sorry. And it is reversible. Example, your eyes melting. Yes, your melting eyes. It's just a clear example of physical changes. No substance is formed. When you bring your ice from your fridge, from your freezer, you drop it for some minutes. You see it do what? It turns to what? It melts to liquid. That is, you notice it does not do what? It does not. You notice it does not form any substance, right? It's still that your water, right? It does not change anything. It does not do what? It does not change anything. That is a clear example of physical changes. Now, one look at the chemical changes. In chemical changes, new substances are formed. Yeah, and they are irreversible. Example, your burning pepper. When you burn pepper, it turns to ashes. That's exactly that new substances form. And that ashes, you can still use it and do another thing in chemistry too. So that's why we say that chemical changes, substances are formed, while physical changes, substances are not formed. Now I want to look into the classifications of what? Of matter. You look in. Matter is classified into two, which is the pure substances and mixtures. Pure substances, example, elements and compounds. What are elements? Elements are just substances that cannot be broken down into simple units. Example, we have our elements like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, etc. And we also have compounds. What are compounds? Say that compounds are two or more elements. That is, when you bring one element, bring another element together, do what? You join them. Example, bringing hydrogen and oxygen together, we form what? Water. Bringing carbon and oxygen together as a gas to form carbon 4 oxide or carbon dioxide. Another example, bringing sodium and chlorine together to form sodium chloride, which is our normal salts. And we move to the mixtures. Mixtures are divided into two, which is the homogeneous and the heterogeneous. When we talk about homogeneous, what comes to your mind? Homo means the same, right? Good. Why hetero means different? So what we're talking about in homogeneous mixtures is that homogeneous mixtures are those mixtures that are what? The same. Example, our salt solution, as our salt water, our air. Yes. And look into heterogeneous mixtures. We say that heterogeneous mixtures are those mixtures that are very different. They don't look the same. Yes. They look different both in their shape and size and everything. Example, we have granites, etc. So these are all the things you know and you're supposed to know about matter. Remember, matter is a very important topic to learn in chemistry. Before you start a foundation in chemistry, you're supposed to know everything around you. Yes. Seriously, you're supposed to know what? Everything around you. So we have come to the point of conclusion that matter is anything that has mass, weight, and can what? Occupy space. I am a matter, you a matter. Everybody around you are matter. Both living and what? And non-living things. And we also talked about change of states, how solid goes to liquid, liquid goes to solid, liquid goes to gas, gas goes to liquid, and so on and so forth. So we have come to conclusion that matter is what? Everything around us, living and one non-living thing. So thank you so much for watching, and like, share, and subscribe to my channel. And thank you for participating in this class today. Love you so much. And please, a mini assignment is given. That is, in the comment section, just write 3 things you know about matter. 3 things you know about matter. Anything you can talk about matter, and whatever. You can add a lot of things. You can add more of what I've not said and more of what I said to know that. Let me know whether you guys are all what's following me. Thank you so much, and God bless you.